Okay, hello everyone. Yeah, yeah today's lecture is chapter 4, descriptive statistic. Okay, you may not want to see my stupid face, so I will close this window. Okay, so let's start. So let me prepare my pencil. Okay. Okay, so today I will discuss the numerical description. Actually, we will discuss center and variability and shape. Today, I will discuss only this, so numerical description for center. And the next time, I will discuss variability and shapes. So first, let's start with example data. So vehicle quality. So it is named JD Power. So it is defect for 100 vehicles. So JD Power, so research that how many defects have founded for each car brand companies for 1 year for per 100 vehicles, and they so collecting the data. So number of defect per 100 so produced car in here. Okay. So that is uh, the meaning of this data. Okay, so then first we need this data. So let's download this data first. Okay. So here is our blackboard, and you can go to this. So here, introduction to business statistics summer, and you may log, so ask ID and password, but whatever. And here in document, you have so data, lecture notes, and so PE ratio and JD power. So let's download this JD power. Okay, here it is, and open it. So then Excel is running, and we found the JD power data in here, from here to here. And here is the brand name, Acura, Audi, BMW, and so on, and Lincoln, Lexus, Land Rover, and Volvo. Okay. Okay. So and then let's go back to uh, the slide. So we have this data, and then we would like to see that where is center of this data. Okay. So here is the explanation of the data. How can the JD Power found this data, and what is the meaning of the numbers? Please read it. First, we can draw the steam leaf plot, or in this case, so this dot plot would be helpful. So this dot plot shows that here is some strange guys, and so here some many so data are concentrated around here, and here is some small guys, and so on. So that is, using this dot plot, we can find where the data are distributed. Okay, and so we can sort the data. Okay. and we can draw the histogram like this. The number of data, which values are between 80 to 100 and 100 to 120. So there is six data between 80 to 100, and 14 data which has the value between 100 to 120, and 10, here is 15 number of data, and 10 number of data are included in the bin between 120 and 140, and one data is between 140 to 160, and one data is included between 160 and 180. Okay, so this guy is that one, and this guy is that one, and so 20. So from here to here, they are included in this bin, and these guys are included in here, this one, and from here to this data are included in here. So we can draw the histogram using the data. And in previous lecture, I've explained you how can you draw the histogram if you wanna using the Excel. So if you wanna draw this histogram, then please use the Excel and watch the video of chapter 3, number 2. Okay. So in this lecture, I will discuss the measure of center. We will discuss many measures of center in here. We will study mean, median, mode, mid-range, geometric mean, and trimmed mean. So most important measure of center is mean and median. It is most popular, and geometric mean is also, but these two are very important. And from time to time, trimmed mean is also reasonable value. Let's study one by one. Mean is actually average. So when you have a data, then you always calculate the average, mean. So it is very common sense. We summate x. So we have xi means that if we have a sample x1, x2, and so on, and xn, so then we just summate first sample, second sample, third and first and nth. So that is summation notation. Summate them all and divide by n. Then that is mean. That is average. So that is, if we can see all the information in a probability space, then that is population mean. So for example, if you can see population mean of one statistic class final exam score, then instructor may see all of the samples, and the instructor can sum the scores, all of the students' score, and divide by number of scores. So then that is population mean. But for example, it is impossible to see the total information of the data. For example, people's weight. So New York citizens' body weight. Somebody wants to know that. New York citizens' weight. Then New York citizen is too large sample, so we cannot see total number of informations. So we cannot calculate the population mean. In this case, we just select small sample of New York citizens and measure the weight and so find this sample mean. So the sample mean calculation is exactly same. Sum them up, sum of all the samples and divide by the number of samples. Of course, this n is strictly larger than the population number, but so if you wanna calculate the sample mean, then it may have difference between population mean. So we will discuss the error between sample mean and population mean, but today we need not to worry about it. So if you can see all the data of samples, so then you can do the population mean, you can calculate population mean. But if you have only some small samples of the population, then you can calculate the sample mean. Whatever they are, so the mean is calculated by this equation. So the difference between population and sample is discussed in chapter 2, in the end of chapter 2. So please repeat this chapter, then you can find the difference. So whatever the population mean or sample mean, so the definition is very similar. So the good property of mean is that, okay, so the real sample value minus it is sample mean. So difference between the real value and sample mean, and sum them up. So sum up this difference, then it becomes 0. That means, so if we have a mean in here, then the distance between mean and realized value, mean and realized the sample, so difference between mean and sample, difference between mean and sample, difference between mean and sample is balanced. So if you have this two-armed weight, then and here is so this distance, so d1 and this distance d2, they are all the negative distance, and that is positive distance. It is positive distance. Then so the negative distance, size of negative distance and size of positive distance, are the same. So this sum of these 3 value and sum of these 2 value are so the same. And finally, so and it is negative value and it is positive value. So sum up this all the data, then it becomes 0. So that means if you have data, so Bob's quiz data. Okay, so then where is Bob's quiz data? Let me see the Bob's quiz data. Okay, for example, Bob take the quiz and he take the 5 quiz and his quiz score was 42, 60, 70, 75, 78. So then average of them, so the mean sample mean of these 5 numbers are 65, for example. So then 42 minus 65 plus 60 minus 65 plus 70 minus 65 plus 75 minus 65 plus 78 minus 65 is become 0. Okay? So that is one good property of mean. Okay, so median is another measure for center. So mean is very good measure for center, good representation of the center. But sometimes mean can be a little so skewed if we have extreme value. For example, if you take the mean, if you have a data, so some data are in here and one outlier is here. So then mean would be stay in here. If you take the mean of this value and this value, then mean will be here because mean should be balanced. So then this mean cannot represent this data because all the data are concentrated in here. So then center should be around here. But mean is far from so mean is because of this outlier, mean is a little skewed to the outlier. So mean is not a good measure for this case if the data are not so concentrated, and it has some outliers, it has some big outliers than mean, so it's not a good so measure for center. In this case, we use the median instead of mean. Okay. So median is the value that, so if we have a median, then it is the value that the lower 50% of data is less than median, and the upper 50% of value is so lower 50%, so lower data of median, so data less than median is covers 50% of total data, and values larger than median covers 50% of the data. So median is the center such that so the lower 50% is less than median, opposite 50% is bigger than median. Then we say that it is median. Okay. In Excel, we can find median using so this median function. I will discuss mean and median again with Excel. Okay. So to find median, first you have to sort the data. For example, if you have 8, so even number of data. So and then you first sort the data. So it is smaller data to larger data. First you sort the data from smallest to largest. So it is smallest value and it is more than so it is bigger and bigger and bigger. After you sort your data, select the value between these two center data. So then that is median if you have even number of data. Okay. And if you have older number of data, for example, 9 number of samples, so it is odd number. So then your sample number is observations, number of observation is odd number, for example 9 number, then first you sort the data from the smallest value to largest value. So it is bigger and bigger and bigger and bigger, and then select the center data. In this case, 9 number of observation. So that is the fifth smallest. So fifth smallest guy is the median, which is fifth largest value is median. Okay? So if you have even number, then you have to select the middle between these two, and if you have odd number samples, then the center guy is the median. So more precisely, if you have data, if you have observation 11, 12, 15, 17, 21, 32, so then we have 6 observations. So 3 of them is lower median and 3 of them should be upper median. So then median value should be between 15 and 17. So median is between 15 and 17. So median value is the average between 15 and 17. So 15 plus 17 divided by 2, then we have 16. So this value is median of these 6 observations. On the other hand, if you have 7 observations, so 12, 23, 23, 25, 27, 20, 34, 41, so here is 3 values. I'm sorry. So here is 3 values. So here is 3 values and here is 3 values, and the first value, the first smallest value is median. Okay? So in this case, median is just 24, which is first smallest value, and on the other hand, first largest value. And for example, so you have 11 data, 11 exam scores, and you sort this 11 data, so from the smallest to largest. So then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data. So then, because it is 11 data, this lower level has 5 data, and upper median has 5 data, and this guy is median. But in this case, it is a little strange because 78 is repeat 1, 2, 3 times, and then it becomes 81. But so you need not to worry about it. This 78, so 78 is repeat 3 times. This 78 is median. Okay? So think about simple. Okay. Yes, so whatever the data is, median is just a 50% so split value. Okay, and median is useful when there are extreme values. If extreme value is that if your data is concentrated in here and one very strange guy is here. So your data is concentrated around here, but one guy is here, then this guy who is far from the other datas are extreme value. If you have extreme value, then you'd better use median than mean. So government statistic use median instead of mean. Yeah. For example, so median income is official center for government statistic because a few very high incomes, for example, very rich guys, Warren Buffett or Bill Gates. So push the mean into somewhere in here. It is mean. Okay. So the mean is if you have very extreme value, then mean is not in the center of the data, but it is a little out of the data which is concentrated. So there is the data. So in this case, you'd better not use mean, but use median, which is in here. Okay, so that's why we use mean and median instead of mean when you have an extreme value. So okay, let's study the median again. So Tom's score is here, 20, 40, 70, 75, 80. So the mean is 57 if you sum them up. So 20 plus 40 plus 70 plus 75 plus 80 divided by 5, then you have 57. That is mean of Tom's score. And median is here. So 2 is less than median, 2 is greater than median. So this 70 is median. Okay, mean is less than median in this Tom's case. Jake's score is 60, 65, 70, 90, 95. So mean is 76 and median is still 70. Okay, so here is two values, here is two values, so 70 is here. So median is still 70, but mean is greater than median. In this Tom's case is different. So mean is less than median. And Mary's score is 50, 65, 70, 75, 90. So mean of this value is 70. Median is also 70. Okay? So in this case, Tom's mean is less than median. Jake's mean is larger than median. Mary's mean is same as median. In this case, if the mean and median is same, then we say that it is symmetric. Okay? And Tom and Jake's case is here. Tom and Jake's case has, based on this information, Tom's mean is pulled down by a few low scores. Okay, so let me clean up. Let's see. Tom's mean is 57, but median is 70. So Tom's case, let me erase them all. And so because of this extremely small value 20, the mean is pulled down. Okay? The mean is pulled down by this 20. So that's why Tom's mean is less than median. Jake case is opposite. So lower boundary, lower part of the Jake's score is so close to median, but upper part of the Jake's score is far from the median. So Jake's case is here is 70, and here is 65, and here is 60. It is Jake's score distribution, and that is median. And here is 90 and 95. So these two guys are far from the median, and these two guys are close to the median. That's why mean is larger than median. And Merit's score is symmetric. So these two and these two are balanced. So and 70 is the center of balanced distribution. So in this case, we say it's symmetric. Okay. Okay. But median is not mathematically useful, mathematically beautiful, because mathematically mean is easy because so mean has mathematical beauty, but the median does not have mathematical beauty. So it is not important. Okay. So another measure of center is mode. Mode is the most frequently occurring data value. It is maybe similar to the mean and median. If data is near the center of the sorted array, tend to occur often, but it is quite different from the mean and median in many cases. Okay. Mode is, so for example, if you have data least score 60, 70, 70, 70, 70, 80, then mode is 70. Mode is 70. So 70 is repeated 3 times, but 60 and 80 is only 1 times, appeared 1 times. So the 3 times repeated data is mode. PET score is that 45, 45, 70, 90, 100. Then mean and median is 70 and 70. But these two are repeated 2 times. So most frequently appeared data is 45 because it is appeared 2 times, and others all appears 1 times. So mode is 45. In this case, all the data appears only 1 time. So in this case, mode is not exist because they are all the same frequency. All the data has appeared only 1 time. So in this case, we cannot find the mode. So Xiao's score is interesting, 50, 50, 70, 90, 90. So 50 repeat 2 times, 90 repeated 2 times, and 70 also appeared only 1 time. So then mode, we have 2 modes, 50 and 90. So mode is the most frequently occurring data value. So that's why we have this result. Okay, and all the data has the same mean and median, So 70 is in the center, and mean is all 70. So if you calculate the mean of each data, then you can find that mean is always 70. Okay, so for example, another example is here. So if you have a data like this, which is a JD power data, so 33 JD power data, then please find that again. So our JD power data is, let me see. So our JD power data. So here is the data we observed, and it is sorted data, and 111 repeat 4 times, and other values are so repeated less than 4 times. Okay, so mode of this data is 111. So 111 repeated 4 times. So mode of our JD power data is 111. So 111 occurs 4 times. So Excel function you can so have a function mode single and data. So you can find the mode using this equation. If the return is sharp and A, then there is no mode. Okay. If you have multiple mode as Shell's case, in this case we have multiple mode. In that case, Excel return, so this function return only the first one mode it finds. Okay. Others, please read others. It's not so important. And so using the median and mean. So using the median and mean, we can find the shape. So I mean shape. So the data is symmetric, then the mean and median is same. Mean and median is same, then the data is symmetric. But if mean exceeds the median, so mean is greater than median. So mean is greater than median, then the shape is skewed right. We've studied skewed right in chapter 3. And if mean is below median, then the data are skewed left or negatively skewed. Okay? So I mean, if mean is less than median, so mode is, you need not to worry about mode. You need not to worry about mode. So mode is not important. If mean is less than median, then the distribution shapes skewed left or negative skewed. This one. If median is less than mean, so mean is greater than median, mean is greater than median, mean is greater than median. Okay, so then the distribution shapes are skewed right, positive skewed. So the graph looks like that. And mean and median is the same or similar. So mean and median is very close together. Then the distribution is symmetric. So left side and right side are balanced. Okay. So using the mean and median, we can find the property of shapes: skewed left, symmetric, skewed right. Okay. Okay, so skewness of this data. So 74 noodle restaurant have so histogram like this. Then in this case, this figure is right skewed. If you calculate mean and median, then mean is greater than median. So we can see that the distribution is skewed right. So in this case, so GPA, the student's GPA histogram is given by this figure. So then you can see that it is skewed left. Skewed left. So in fact, the mean is 3.17 and median is 3.20. So mean 3.17 is less than median 3.20. So in this case, the distribution is skewed left. Okay. So it is negative skewed, left skewed, skewed left, negative skewed. So using the mean and median, we can find the shape skewed left or skewed right. Okay. Okay. Let's go to the geometric mean. Geometric mean is, from time to time, geometric mean is used to analyze the stock price data. So stock price is always positive. So stock price is very much affected by the return. So in this case, we use the geometric mean. Whatever the application, let's define the geometric mean. So geometric mean is multiplication of each observed data and take the nth root. So then that is geometric mean. Okay. For example, if you have a data 2, 3, 7, 9, 10, 12, then the geometric mean is, so 2 times 3 times 7 times 9 times 10 times 12 and take the, so sixth root. Okay. So then we obtain, so multiply them all and take the sixth root. So then we obtain the 5.972. So that is very difficult to calculate because the 4, 5, 3, 6 to the 1/6 power is very difficult to calculate. So you would better not calculate by hands. It is impossible to calculate by hands in these days. So you have to use the good calculator, or in Excel has the function to calculate the geometric mean. Okay. And growth rate is given by this equation. So growth rate is used for some investment and finance, but it needs a time series data. So if the JetBlue revenue is this number at so 2006, this number at 2007, and 2010 we have this revenue, then growth rate of this so growth rate always involves the time. So the data should be work together with time. And growth rate is, in this case, 1, 2, 3, 4, 5 data. So it is 4th root of 3779 divided by 2361 minus 1. So then you can obtain the growth rate. Of course, the growth rate is not easy to calculate by hands, so you have to use the calculator. And mid-range is that, so maximum value of the data plus minimum value of the data plus maximum value of the data divided by 2. Then that is mid-range. So JD power data case, 83 is the minimum value and 170 is the maximum value. So 83 plus 170 divided by 2 is the the mid-range. So trimmed mean is that, so please imagine the diving, so Olympic game of diving or acrobatic, or so the gymnastic or figure skating or something like that. So when the referees give some the score for one player, then the chief referee cut off the maximum value of the score and minimum value of the score, and then so the chief referee just so sum up the scores in the middle, and then give the average score using the values in the middle. So first we remove the maximum value and remove minimum value, and then calculate the values in the middle, and so calculate average based on the data in the middle. So in this case, this kind of so the calculation is called trimmed mean. So trimmed mean is calculated like any other mean, except that the highest and lowest k% of the observation sorted data array are removed. So if you have data values, so then if you have 100 data values, and first you sort them all, so the smallest one, second smallest, and 99 smallest, and 100 smallest, so values. And if, for example, if you want to calculate 5% trimmed mean, then you just cut so 5 smallest values and 5 largest values, so that is 95 to 100 and 1 to 5. So 5% smallest value should be cut off, and 5% largest value should be cut off, and calculate the mean using in the center 90% of the center value should be used for calculating mean. Okay, so in this case we say that it is trimmed mean. So in Excel function is this one. So if you want to calculate 5% trimmed mean, you have to put 10 in here, because 5% up and 5% down is the 10. Okay? So please be careful if I ask you that 5% trimmed mean, then you have to set 10% in the parameter of Excel function. So in JD power case, so 5% lower value, 5% of 33 observation is 1.65. So it is truncated to the next lower integer. So it is 1. So that means the first smallest value and the last value, if you sort the data, and first and 33rd value, so smallest value and largest value should be removed, and use the 31 observation to calculate mean. Then you obtain the trimmed mean. Okay, so using the JD power, we can calculate mean, median, mode, geometric mean, mid-range, and 5% trim mean using this Excel function: average, median, mode, geometric mean, and mid-range. So the Excel function does not have mid-range, so we have to do like this: mean of data, max of the data, mean of data, max of data, and divide by 2, and trimmed mean. So then you can obtain these values. Okay. So let's do it. Let's do the calculation. Let's do this calculation using Excel. here we have JD power data. Okay. So then let me copy them and so paste it in new Excel function. Okay, so then that is data. First thing we have to do is sort them. To sort this data, we just select here this one, sort data. So then we obtain the smallest to largest values. Okay, first let's calculate mean. So to calculate mean, we use the function of Excel average. Average of data. So then that is mean. Okay. So let me copy the data again here. Because copy, paste again. So that is not sorted data. And let's sort it. Let's sort it. So then that is sorted data and that is original data. Okay. So we take the mean for original data. Okay. So it is the same. We can use the original data or sorted data, whatever it is. So it is the same. Okay. So let's use the original data only. Okay, and median. So to calculate median, just use the function median. Median of A1 to A33. So then you obtain the value median. Okay. So then shall we check that is correct? First sort the data, and we have 33 observations. So median will be where? 17. So 17th smallest or largest value is the median. Okay, so 17th. If you select 113, then the lower area of 113 has 16 so observation, and upper 113 data has 16. Okay, so the number of data which has larger than 113 is 16. So here is count. Please find the count 16, and the lower 113 is 16. So this value is median. Okay. And mode. So mode is that use the function mode single for A to A33. So then 111. Okay, so 111 repeated 1, 2, 3, 4 times. So mode is 111. And geometric mean. So you have to be careful. Geometric mean can be used only for the positive data. If you have at least one negative value in your data, then you cannot use the geometric mean. So geometric mean. So let's use the function of geometric mean. So from A1 to A33. Okay, so let me stop it. So please see this equation. So geometric mean A1 to A33, then we have this geometric mean. So geometric mean is so difficult, so you cannot calculate it by your hands. You need good calculator. When you take the exam, so you can use Excel or calculator because it is online course. So if I ask you the calculate geometric mean, then you can use Excel or you can use the calculator. Okay. And what is mid-range? So let me check the name. Geometric mean and mid-range. Okay. Mid-range. So then it is actually minimum value between A1 to A33 plus maximum value of A1 to A33 divided by 2. Okay. So minimum plus maximum divided by 2, then that is mid-range. So we have 126.5 mid-range. And trimmed mean, geometric mean and trimmed mean. So trimmed mean 5%. Let's calculate trimmed mean 5%. So then be careful when you calculate trimmed mean 5%, you have to use 10%. Trim mean A1 to A33, comma, percent is, we have to cut 5% lower values and 5% upper values. So 5 plus 5 is 10. So we have to say that 10%. 10% is 0.10. So then we obtain the trimmed mean. So then here is mean, median, mode, geometric mean, mid-range, trimmed mean. So repeat. So to calculate mean, use the function average. To calculate median, use the function median. To calculation mode, use the function mode, single. And to calculate geometric mean, use the geomean function in the Excel. And to calculate mid-range, you have to use this complex, equation, but it is not complex. Just to calculate mean, max, divided by 2. So then that is mid-range. Trimmed mean, to calculate trimmed mean, you can use the trim mean function given by Excel. So you just give the range and it is 5%. So you have to cut off upper 5% and lower 5%. So it is sum of 5 and 5 is 10. So you have to give the 0.1 instead of 0.05 in here. So that is Excel's Excel function designed by like that. So you have to just follow the Excel's policy. So then you can find the trimmed mean. So all of this, center estimators are studied. We've studied mean, median, mode, geometric mean, mid-range, and 5% trim mean. They are all the center statistic for represent center of the data. So next time we will study the measure of variability. So yes, and the measure of variability. So next time we will study the measure of variability. And in that case, we will study how the data are diversified. Okay. Thank you so much. So this lecture is over, and so let's start again with this measure of variability in next